Hi, I'm Mustafa, and I worked on the front end for Course Planner. In this demo, I'm going to walk through how a student uses the platform to manage course planning conversations with our AI assistant. So I actually do have an account, but for the purpose of this video, I'm going to create one. So we can just click Create Account. I'm going to enter in my email. And then here, we can just enter in our password, making sure it follows all these constraints. Then we can click Create Account. Then you'll be prompted to just go and verify the email. I'm going to go and do that real quick and then get logged in. Now we can get logged in with the account we just set up. Once I'm logged in, I'm brought to the main interface. On the left, you can see all my chats. Each chat represents a separate planning conversation. Things like how to fit a stats miner or comparing EECS 281 versus 370. At any time, I can switch between light mode and dark mode depending on what's easier to read. I feel like dark mode tends to be nicer if I'm working at night, and the interface updates instantly. Most students don't just ask one question when they're planning courses, so Course Planner separates everything into different chats. For example, here I can open up the How to Fit Stats Miner chat. Then I can switch to the EECS 281 versus 370 chat, then to winter conflicts. This lets me keep different planning topics organized without mixing everything into a single thread. If I ever lose track of a conversation, I can use the search bar at top. For example, if I type EECS, that list will filter automatically to show only chats where I talked about EECS classes. This makes it easy to jump straight into an older planning question. If I want to start a completely new thread, I can just click one of these new chat entries. This chat opens with a blank conversation, and I can start asking new questions without affecting my other threads. For example, I might type, what courses should I pair with EECS 497 if I want a lighter workload? The assistant processes the query and responds with course recommendations, workload considerations, and an explanation that helps me decide how to balance my semester. I can ask a follow-up question in the same thread like, is EECS 445 too much alongside 497? And the chatbot keeps the context for the specific chat so it doesn't mix information with other conversations. And here we can see our response. So that's how a student uses Course Planner day to day. Switching between planning topics, searching old conversations, creating new chats, interacting with the assistant, and adjusting the interface. Before I transition to the technical breakdown, I want to quickly point out how we communicate the value of Course Planner to students right from the homepage. This page summarizes what the platform is really meant to do: help students graduate on time with confidence. It's a single place where academic planning, course advising, and long-term scheduling come together. Here, we highlight 6 core areas students consistently struggle with: picking the right courses, managing schedules, tracking degree progress, collaborating with peers, understanding academic patterns, and making sure they stay on track for graduation. Even though not all of these features are fully developed yet, this layout shows the direction the platform is heading in. We also use a section to show the scale of the problem we're solving. Course planning affects students across all majors and universities, which is why Course Planner is designed to be adaptable to many different institutions. Overall, the homepage reinforces the idea that Course Planner is more than just a chatbot. It's meant to be a complete academic toolkit supporting students from their first semester through graduation. And with that overview of the user experience, I'll hand it off to the rest of the team, who will walk through architecture, implementation details, and the challenges we solved during development.
Now we're going to go over the backend of CourseGPT. The backend of CourseGPT is a pipeline powered by Gemini 2.5 Flash. We wanted to use Gemini 2.5 Flash API because Gemini has access to hundreds of online resources such as Rate My Professor, College Confidential, and Reddit to provide information about professors, courses, and all that recommendations that the user would like. We also wanted to make sure that given this wealth of information, we're able to provide a well-informed response for the user. So we asked the user to input the question, and then we also want to input the school to give context to Gemini about what school the student's attending in case there are different schools with the same course code. Since we're trying to roll out this application for University of Michigan students, we provide University of Michigan as our school. Given the school in question, we make a prompt. Our prompt asks Gemini to take the inputted names and label them so it's easy to query information from public forums such as Rate My Professor in order to get professor reviews. We also ask Gemini to obtain reviews from Reddit in College Confidential and other public forums given the class code. From there, we ask Gemini to save the context in case the user asks more questions, follow-up questions. And then lastly, we want Gemini to provide a structured output formatted with headings so the user can easily navigate the response once it's forwarded to the front end. Now we're going to go over an example. Here, the question that the hypothetical user is asking our Course GPT application is, how's the workload for EX42? Should I take it with Peter Chenemano's K? Do you recommend taking EX445 if you want to do machine learning courses? And now that we've inputted this question into our agent, we're able to get the response. And as you can see, our response is clearly labeled with sectioned headings, such as professor reviews and course reviews. For the first section, we see that we're given information about the overview, the teaching style, and specifics for each professor inputted in the question. And then we're also given information about the course reviews in the next section, such as the workload, content, and difficulty of each course, and also the description of each course. Lastly, the last part of our question was, what should we take if we are interested in machine learning? We're given a recommendation from Gemini right here, which where the Gemini recommends that we take EX4045 if we're interested in machine learning, since 482 is more systems and low level. So yeah, that is the backend for Course GPT.
Throughout this project, our team followed a full end-to-end product development process, from problem definition to design to implementation to testing and finally to deployment. We started off with user research to understand the frustration students had when fragmenting advising tools and course planning across many different platforms. From there, we built early prototypes, and we ran through multiple rounds of usability testing with several users and collected their structured feedback to continuously improve our UI and system behavior. And by the end of the process, the course helper evolved from a simple ideation concept into a fully built production level application that has real performance metrics and rigorous testing behind it. However, over the semester, we did face some challenges, and two of the major issues that first stood out to us was in our final testing phase. So the first major issue was when we identified a specificity bug, and in this issue, users asked complex or narrow scope planning questions. The system would sometimes produce overly generic responses instead of just specific recommendations. So through the different detailed bug reporting and prompt analysis that we had, we traced that back down to how the queries were being parsed and passed into our LLM pipeline. So we ended up redesigning the prompt structure to better extract user intent and also added stronger instruction constraints and just overall improved context formatting moving forward. So these changes really allowed for us to have improved response accuracy and just an overall more enhanced UI. And the second major issue we faced was actually a sudden API failure caused by external model limitations. And during our testing phase, the Gemini integration that we had began returning consistent errors across all the different prompts. And those were even for valid and good queries as well. So this appeared to be a system bug at first, but after we investigated it, we determined that the application was just being limited by the Gemini API or temporarily blocked out at the provider level. So this whole experience really highlighted a real world engineering constraint, and we realized that even well-built systems still remain dependent on the reliability and other limits and external AI services as well. So it just reinforced the importance of planning and error handling, as well as just monitoring our systems. Although course planning is fully functional, there are several high impact future improvements we've already identified to continue to improve on. So, our first improvement was to resolve the issue of chat title and conversation history. So, there are different chats that currently function correctly, but in terms of the long history tracking and the automatic naming, we'd love to improve on that just to make it a more smoother process and easy for the users. We also identified several stretch goals. So the first one being advisor dashboards. So this is where university advisors could monitor student progress throughout their 4 years of undergrad or however many years they pursue to study at a scale. And Our second improvement would be the multi-university support feature. So we would eventually allow other course helpers as well as universities to use our platform and to just scale beyond a single institution here at the University of Michigan. And we believe together that these features would really transform this app from just a single use planning tool into a fully scalable academic advising platform. So to conclude, this project represents a complete design to delivery cycle. And from our early sketches and UX testing to our fully backend scalability and real performance targets, we determined that Course Helper demonstrates both strong execution and also just real user value. And these challenges that we face push us to refine our system at the production level and just a future roadmap reflecting a platform that's not just built for this class, but also real world applications.